Today we have quite a fascinating topic, actually. We're joined by Marx Zang on AI, machine learning, and economics, and the research he's been doing into those areas. Marx, welcome.
Hey Xavier, good to be here.
Now,
Yeah,
I
great to
think so.
see so many people. Yeah, that's it. Yeah,
Sorry.
great to see so many people here.
It is. They're starting to roll in now, which is fantastic. Now, I do need to ask. This is your first time with us on one of these, but it's also your first actual Twitter space. So, welcome to the world of X Spaces.
Excited. Thank you.
I do need to ask quickly, Marx, Marx. It's an unusual name. What's the story behind that?
Yeah, so I think I honestly I started with Max, which is a name given by my English teacher when I was in primary school, I think. And then
Uh huh.
uh, and then when it comes to high school, I had three Max, and then I decided I want to change the name. Yeah, I'm like, "Yeah, let's make it a bit different, and then go with Marx. That's the
Oh,
story.
fantastic.
Yeah,
It's the sort of, but not quite similar progression, but my actual name being Xavier.
yeah.
All through school, primary school where I lived, high school, there were no other Xaviers. I was quite unique. But then when I moved to a bigger city, all of a sudden I met another Xavier in my workplace for the first time ever, and I was blown away. And then he turns around and he was confused as to why I was so excited because he had three Xaviers in his high school class.
Yeah.
Anyway,
Huh.
look, let's kick it off. Really keen to get into the talk here today. Um, I'll hand it over to you to start off with, if you like. Give us a bit of an introduction of yourself, your history, how you've come to be where you are, and then got into this area of interest.
Yep. Thank you. So hi everyone. My name is Mark Zang, and I'm currently a researcher at Gensyn. Most of the research I do are definitely decentralized AI. I also work a lot on market design and some of the these. I also used to work on like a lot of decentralized finance topics. So I'm currently a PhD, last year PhD in economics at the University of Tokyo. But uh, my background was mostly in mathematics. I did my undergrad and master in pure mathematics. So basically, that's where my foundational skills come from. And then my PhD, I started as a macroeconomic focus, and then I think it's in the second year of my PhD where I had a earlier collaborator who asked if I want to do some machine learning research. So
Hmm.
basically, I applied my knowledge in math and dynamical system, but basically kind of not reshape, but telling the story of a machine learning theory from a dynamical system perspective. And I got accepted to New Rips in 2024. That's how I met everybody here at Jensen too. And
Right.
yeah, then I was why don't I put some on my econ part of the research and to see how is it connected with machine learning, artificial intelligence and stuff. And also at that year, I think we saw a paper by OpenAI, which is they were modeling, they were training those agents, training those LLM agents using a really basic economic term, like a game from like a simple game from game theory, and then they
Hmm.
had a really good performance. I were like, can we do anything on top of that? Can we? Is there any more game theoretical stuff that we can get into this game design to make it more efficient and stuff? So that's how I started my journey in ML and econ, and and this paper was, I got very lucky too, and well, I got a lot of setbacks beforehand. I got rejected by those top conferences twice, and then I got accepted uh, last year's New Rips 2025, and it was a cool journey, fun journey, and that's also built a lot of foundation of what I'm doing here at Jensen too. Yeah.
Fantastic. Um, why don't we jump straight into it and just give us an outline of what you've been looking into, what you've discovered, and see if we can explain some of this relationship between economics and AI to everyone out there.
Hey, yeah, for sure. Yeah. So I think I think everybody here should be more like should be more familiar with machine learning and AI, those like really heated topic recently. So I want to start with what is economics? I think a lot of people think of economics or like it's studying like the fiscal policy, studying monetary policy, it's studying like all those things like federal, what does Federal Reserve do, and those kind of
Hmm.
like really bigger topics. I think that's true. That belongs to kind of like macroeconomics or like what we call like in like macrofinance. But I think economics is like the science that's studying how individuals like interact with each other. That's my basic understanding. So basically, even if you want to study like a macro kind of effect of some policies. You start from individuals. You start to find individuals in the economics and how they act and their rationality, how the equilibrium is reached. And then we
Hmm.
use those kind of models to estimate, to calibrate to the current data we have. So I think it's always the individuals. So the reason why like and like it's so it's starting study the individuals, right? So if you look at what's like a big, I would say like a subdivision of this machine learning studies is like a good example would be studying the interaction between agents, right? Between agents. Agents
Right.
are like the individual, like humans, like in the society. And how do we make agents interact? How do we set the game for the agents to interact to achieve the kind of performance we want to achieve the kind of performance we want? And secondly, how do we design those games so that those good equilibriums that we want can be reached in a efficient way? That's how economics could be applied to the maybe training, post-training, or like design interaction of agents. I think a really if we look at the history, the those topics or those contents have been used in machine learning studies for a while. If you look at the famous paper called Generative Adversarial Network, which is they
Hmm.
were kind of using this like that's basically they were training those like Go agents, right, AlphaGo, to compete with each other so that it can get better. So rather than training all those outside data that's given by those like famous Go players, they were training those agents to go play against itself, right? So it's improving on playing against itself, and it's getting some new strategies or new like data that's generated from it. And that's basically some contents that where they borrow from game theory that they use to train their models or train their agents to make it better, right?
Just
So
just
yeah,
to, just to pause there for a sec. When you're talking about Go training, that's some of the early AI attempts on training and research was using the Chinese board game Go.
yeah,
Is that correct?
yeah. That's right. That's right.
Excellent. Just wanted to clear that up for people who may not have been familiar.
Oh yeah, sure. Yeah.
And how is
So
that? How has that led into the current state?
yeah, so if you look at the some recent papers on, so if you look some recent papers on like how the design agents, I think it so rather than those simpler board games like Go or like chess, now we have like so many more games, right? Like I don't know, I don't really play games, but I know like League of Legends, those kind and those like really famous like online battling games and stuff. I think uh, so you can see a lot of papers that they also train agents to play those games. So if you want to put like give those agents like train those agents to play well or play efficiently, one thing you have to do is like you need to design the reward function as in like machine learning as in training, right? So those reward function is basically you have to tell those agents what is good and what is bad, right? And
Hmm.
a lot of times when you so if you so for many games right now like the for example like for games like Go or chess, the reward is pretty easy to design, right? Because you know when you will win and when you are closer to winning and when you are closer to losing, right? So basically, and you have some limited action space where you can move like your queen to this place or move your some like other characters in different spaces, right? But if you look at current the games that we play now, it's much more complicated, right? And also it's becoming harder to estimate what is your harder to estimate the effect that your next step's going to have to the whole like to the game as a whole, right? So I think that's where the sense of economic design, or what we call mechanism design in economics, come into play, where you have to design those mechanism to give those training agents a feedback when they like take an action, right? So for
Hmm.
example, if the action was like very early on, how do you let them know it's a good action or bad action, right? And how do you design a chain of reward when like your agent was doing some actions in the chain? How do you design those kind of reward? So those are a lot. So those elements are actually studied extensively in economics.
Incentives, rewards, decision making,
Yep,
the decisions that people make.
that's right. Yeah, yeah,
Excellent.
yeah.
Yeah, carry on. What have you been researching in this area, and where is the field going?
Yeah, yeah. So I think one thing I recently like I basically give some like past examples of how economic research interact with like machine learning studies for training. But to me, I'm more like I mentioned earlier, there's a field in economics where we call mechanism design. So,
Hmm.
so you can see it. So there's stuff called game theory, right? Basic game theory is you know that how these people will act, and you have a basic setting of the game. You try to study, you try to find the equilibrium of the game, right? And that's the study of game theory. But mechanism design is like something in reverse, which is I have something that I want those agents to I have some like desired behaviors I want those agents to do, right? I have some desired actions. How do I design this game? How do I
Hmm.
design the incentive? How do I design the rules? How do I design the interaction mechanism so that those equilibrium can be reached from my design, from my mechanism? So basically, I know the result. I'm trying to design something that make those agents into collective interaction to converge to the result. That's basically what I'm doing. So, uh, and I think I so those are also something as you can see from my description. It's really close to how we design those reward function in machine learning. How we design those uh, uh, like different loss functions. How do we design those reward functions in training and post training, or even like uh, sometimes we want to save those resources. We might try to design those games in a like training free environment. So that's basically what I'm looking into at Gensyn right now. And here is if you as you can see, we have this recent release of Delphi, right? Delphi is running
Yep.
on the LMSR, which is a form of automated market maker prediction market. And so prediction market is also a kind of mechanism where the designers use to aggregate information. So the natural question becomes, how do we design this market, or how do we design the price function? How do we design the cost function to make sure that people contribute their true like belief, they contribute their true private information? As so I think so when we aggregate information, there's the first thing we could think about is like questionnaires, right? We give people questionnaires, we ask their belief, or their what they believe what is best. But how do you incentivize to give them to give their like true belief, right? Because there's no uh, value for giving true beliefs, or there's no incentive for them to do so. That's why
Right.
prediction market is kind of like invented, right? So basically, we give them some like incentives for them to. So if your belief is correct, or if your belief is correct enough to the truth, then basically you are rewarded. That right? So that's like a so prediction markets is also a kind of like a so how to design a good prediction market is also a mechanism design problem in the field of like learning, like in the field of like online learning, or in the field of like economics, you can see. So I think so from my perspective, it's more like analyzing those problems from a more econ perspective. Is how do agents really going to behave when they're in this prediction market? So if you look at the prediction market literature, it's mostly studied by computer scientists, and also
Hmm.
like yeah, so computer scientists tend to uh, like it's mostly from a quite a theoretical perspective that computer scientists want those to be computer scientists, mathematicians want things to be like really elegant. Those theoretical computer scientists, they make some simple assumptions on the traders in the prediction market for LMSR, right? If you look at those papers, they were traders are mostly uh, like risk neutral, and then they said, and how they prove that the prediction market is good is there's a bounded loss from the market maker, right? For the market creator. But if you put this into a real context, like real world context, if you look at those, uh, if for example, if I really want to host the prediction market, LMSR is the most elegant, right? Like so far, elegant, easy, and all those like components in uh, like mechanism design is satisfied, where there's incentive compatibility, there's path independence. But if I'm a real market creator, I want to create my own LMSR, I'm basically bounded to lose money. That's that's what like truly is. So if I'm trying to understand this prediction market design from a economic perspective, is like I am as a rational market maker as a rational market
Hmm.
maker, what is the goal I'm trying to achieve by establishing this prediction market that I'm bounded to lose some money at the end? And what kind of market design should we implement to make sure that I don't lose as much, right? That's one thing. And also from the trader side, they make simple assumptions on traders being risk neutral. And my concern would be if they're not risk neutral, right? If they're not risk neutral, how can I incentivize them to contribute their own belief, their true belief? So that's basically
Right.
what my research here at Gensyn is. So I'm trying to look at those problems rather than from a really theoretical, really like those beautiful kind of theoretical perspective. I'm trying to think of if I'm a rational agent or I'm a like a rational human being, or even I could be someone's like someone digital twin, right? Trying to invest, try to put money into the market. How would I behave? And if that's
Hmm.
the case, how do I design a market that might break those elegance from a theoretical, like from theory, and then make this like a market more lively, make this market more like bring more engagement to those kind of markets. So that's basically
Right.
what I'm trying to do here from agents. Yeah.
The challenge of trying to elicit the most uh, how do I say true, correct, genuine information, and what incentives are required to draw that out of participants.
Yeah. That's right. And also, like they always assume that there's a homogeneous like traders, right? Homogeneous
Hmm.
belief contributors, but that's not true at all in the real world, right? We all have different beliefs and we all have different risk preferences, right?
The great economist's assumption that all actors are rational.
Yeah. And yeah,
I'm certainly not always rational.
yeah, yeah, right. And then this is where we can borrow a lot of theories or like practices from econ, where they have study of bounded rationality, right? They have different, or they have bounded rationality. They have what they call rational inattention, which is I only have this amount of attention, and I have to allocate between different information sources, right? So how do people behave when they have limited attention or when they have
Right.
bounded rationality? That's like a really intriguing topic to study in econ, and also it can be brought to like machine learning and learning algorithms and such. Yeah.
Okay, so this is going into individual actors' resource allocation in a way.
Yeah.
Their
Yeah.
attention, their choices, whether it's their physical resources or their inherent resources as well.
Yeah.
How does that apply to AI, LLMs, machine learning, and the things that we're building currently?
Yeah, that's a really good question. So I'll give you a story like how this really fits in. So let's go. If we can go back to the paper that I got, my paper got accepted New Rips 2025. So when I was presenting this to my professor, right, he's like, I'm trying to do this training-free algorithm where I want those agents interactions to converge to a really good equilibrium, right? And then, but basically we have a ground truth, and we have a ground truth for what those what the answers to those questions are, but we're trying to design a agent to converge to equilibrium. Then my supervisor, who is like a really old school economist, he's like, if you if you want those really good results, you should do optimization rather than equilibrium. I'm like, yeah, here's the case. Because the algorithm that I'm trying to derive is that I want this algorithm to be training free. That is in the case if we don't have enough resources, right? If we only have certain amount of resources behind each agent, how do we design a mechanism so that Z can converge to a good equilibrium that we want? So it's like a constrained optimization problem. So under this constraint, we try to design the mechanism so that they converge. So that's basic. So as a human, we have limited attention, right? And as agents or as machine learning
Hmm.
models, you have limited computational resources. So I think in some ways those are the same, right?
Right.
That's just my belief. Yeah.
And where is that going in terms of uh, creating these markets? How are you addressing that challenge, that limitation of resources?
Oh yeah, yeah, for sure. So I think one thing. So that's also something that's been assumed in a lot of those prediction market literature. If you
Hmm.
look at those literature, they were basically assuming all the traders or all the like information contributors, they have infinite wealth. Like they can always correct the belief if the current market price is different from their true belief, right? So that's assumption. But when you think from like a real perspective, right? Like if the market is really liquid, right? It has a lot of like initial SID liquid, and then there are a lot of participants, a lot of money in the market. I won't be able to really like move the price as however much as I want, right? So that's basically when we're trying to analyze this from the economic perspective, we try to give those traders or the participants more attributes, right? It's not like for example, the market creator, they might be willing to sacrifice some of their like initial liquidity, their fund to for like some kind of collective truth, but they may not want some huge infinite amount. That's
Hmm.
what we're gonna assume. And then for traders, sometimes a trader might have, or sometimes a participant might have a really important private information they want to contribute to the market. But in that sense, their personal wealth or like their resource is limited, which means that even though they have like this really, really important private information, they're not
Yep.
able to just contribute it fully to the market so that the market price can reveal the true like aggregation of all those personal private information. So I think that's what we're trying to study. So it's not like always elegant where people always have the enough wealth to change the market price to reveal their true beliefs. So I think that's the take I'm thinking from like this perspective. And the market should be kind of like should be we can break some like those elegant assumptions so that the market
Mm.
is better suited to agents with limited resources. So that's basically my take from like on the study of prediction markets or mechanism design as a whole.
Right, right, right. That's I was thinking through, trying to form a thought while you were speaking that the basically equilibrium almost requires unlimited resources, unlimited
Yep.
rationality, and
Yep.
unlimited willingness to
Yep.
participate.
You're right.
And that's very hard to achieve in humanity,
Yeah.
um, and also clearly amongst machine learning, particularly
Yeah.
on the physical resources side.
Yeah. Yeah.
That's
And
fascinating. I think Various people may have been wondering why I've been focusing on prediction markets throughout several of these talks, and within Gensyn itself. But what you're explaining actually quite neatly shows the advantages of research into this particular area because of those decision making,
Yep.
training, reward, and incentive structures,
Yep.
which is brilliant.
Yeah,
What
thank you.
what other areas outside of uh, a, a, um, a prediction market could this be applied to?
Yeah, I think that's so. I think in general, if you look at a lot of those um uh so let me see. So I think if you look at like this crypto or this crypto as a whole, right? It's all about like decentralization, right? And
Hmm.
then so under this like purely decentralized like economy or this decentralized environment, mechanism design is basically the like the holy grail for this. If you can think about like mechanism design is how do we design those environments to incentivize those those like decentralized agents to act in a good way that we want, right? So I think the whole like the any design in the world of like Web3 crypto or this decentralized with decentralized nature is just it's always fell under the study of mechanism design. Like it's
Hmm.
like you cannot really think of everybody as a good actor, right? You want those you want minimal assumptions on on the participants, like on how good those participants are.
Hmm.
And then you kind of design this mechanism around that so that you incentivize most people to act good, right? If you look at the like the early like consensus mechanism that's always been used in a lot of like famous protocols, right? So
Hmm.
the
Hmm.
consensus mechanism is like like a, a really neat kind of study in the or it's been like studied for a long time in the field of mechanism design and also voting mechanism, right? So it's like yeah, so it's been studied and there's a lot of axioms in the economics which define whether a mechanism is fair, whether a mechanism is so like they have the definition of fairness, right? And then how do we design a fair mechanism is that if this mechanism abide with those axioms that fall under the fairness in mechanism design. So I think there's a lot of stuff we can borrow or we can learn from the field of mechanism design in the field of like a lot of environmental design or like mechanism design in the field of like crypto and Web3 and decentralization.
Absolutely, there's quite a lot of similarities from what you've been discussing.
Yeah.
The one little question bouncing around in my head, you mentioned that a lot of the mechanism design and the research
Hmm.
around economics and incentives is to have AIs, LLMs,
Hmm.
machine learning participants
Hmm.
act in a certain way. Now, is
Yeah.
that act in a way that we want them to, or simply act in a way that we can predict?
Yeah. I think that's a really good question. I think so. I think acting the way it's so act in a way that we want them to, or the whole environment or the whole community want them to. This is kind of the goal. So basically, when we're trying to design those reward functions, right? It depends on how you define those reward functions. I think for us, what we're trying to do like at Jensen is that we want to the this reward or this mechanism we want to design is try to maximize some welfare of the entire community, right? The
Hmm.
welfare of the so if we use welfare as a reward, then basically our incentivization mechanism would lead to uh, like how do I say like this utility of the entire crowd rather than
Yep.
just yeah. So that I think that's our goal here. So it really depends on how you how you design this kind of utility, right? How what kind of utility you're trying to maximize. I think that's what it is. Yeah.
And using welfare as an example, that plays
Yep.
into self-interest, which runs all the way back to what you spoke of at the start, and
Yep.
the basic tenets of game theory.
Yeah. Yeah, like how you balance this like self-interest, right? How you balance this self-interest with collective kind of
Hmm.
utility, collective welfare. I think that's
Yeah.
like a like a really meaningful question to study in the field. Yeah.
Well, we'll give an individual actor the most benefit to themselves that also benefits
Yep.
the wider
Yeah, and
community.
and that's really it's really hard to like to strike a balance between those two. So that's what we're
Mm,
working on here. Yeah.
fantastic. That's
Yep.
been absolutely fascinating, Marx. Thank you so much for spending your time. I know it's quite late for you over on the other side of the globe.
Yep.
Um, let's bring someone up. Henry's got his hand up. Let's see what Henry would like to ask. Anybody who wants to ask questions, if I could just remind you, keep it to this topic today. That would be amazing. Let's say hi to Henry.
Hey.
Connecting.
Hey,
Henry,
Henry.
welcome. Henry, can you hear us?
Hey.
Nope. Henry's not there. If anybody else wants a quick question, feel free to raise your hand. Otherwise, we will wrap up quite shortly. Speed X, there's another one. It's taking a little while to connect.
Yeah.
Hope that's not my end.
Same here.
No. Well, Marx, before we speak to SpeedX, we will wrap up shortly. Are there any particular points or thoughts that you would like people to make sure they take away from this session?
Let me see. So I think any takeaways? It's pretty hard to say any takeaways at one. It's just I just hope everybody kind of gets at least something from today's talk. If I'm not being too technical or anything, but yeah, that's that's just my hope. Yeah.
No, I think it's been marvelous. I
Thank you.
think that it's actually quite simplified some of the reasons as to why we are conducting this research and
Yeah.
building these products, and wrapped it all up quite neatly in some very understandable concepts. So thank you very much, Max. I really
Thank you.
enjoyed that.
Thank you very much.
Um, I hope everybody else did as well. As always, thank you all for taking time out of your day to come and join us.
Yeah.
Jump into the Discord with any further questions, and we'll make sure to follow them up there.
Yeah.
Otherwise, keep an eye out for the next schedule of events for next week, and we will see you then. Thanks, everybody.
Thank you.